derive the OLS in the simple case, in the simple linear regression. Well, I want you to understand what are the things that you need in order to make this derivation. So what are the things that you need? One, well, you need the first order conditions, and you need to know the properties of the summation notation. If you know these two things, it's very simple, because look what you're doing. Let me give you a parallel of this. If I told you something like x plus y is equal to 5, 2x plus 3y is equal to 8, could you find the x and y that satisfy these two equations? Of course. What do you need in order to do that? Well, you need these two equations, and you need algebra, right? So this equation, together with algebra, will lead you to the x star and the y star that you're looking for. Okay? You should all be able to do that. Well, we're going to do exactly the same thing when deriving the OLS. What are the first order conditions? It's exactly the analog of this x plus y is equal to 5, 2x plus 3y is equal to 7. Why do we need the properties of summation notation? Because the algebra that we're going to do on this first order condition will involve a lot of this summation notation. So if you don't know it, you're going to get the algebra wrong. Okay? So you're not going to find the optimal x star and y star. There's another subtle difference, or a small difference really, that shouldn't bother you very much, is that you all the time have thought about the x and the y as being the variables you're trying to solve for. Okay? What are the variables that you're trying to solve for now? Yeah, beta 0 hat and beta 1 hat. The x's and the y's are actually constants, are just a bunch of numbers. Okay? That's all that they are. So from the first order condition, which I've derived in a previous video, but what you have is this sum of yi minus beta 0 hat minus beta 1 hat times xi must equal to 0, right? That's one of the first order conditions. It has a minus 2 in front of it, but I'm not going to be bothered with it, right? What's the second one? The second one says that the sum of xi times yi minus beta 0 hat minus beta 1 hat times xi is also equal to 0, okay? Two equations, two unknowns. What are my unknowns? Here are my unknowns. Beta 0 hat, beta 1 hat. Think of it as like your x. Think of this as like your y. The same process is what you might have done in your GCSEs or your A levels. You have two equations, two unknown, find it. The only complication is that you have summation notations floating around, and you have to deal with those summation notations, okay? But in principle, it's as simple as that. How do you solve this equation here? What is the first step that you do? You rearrange. Maybe you kind of go and say x is actually equal to y minus 5, okay? And then you take this and you plug it into the second equation, right? And then you say 2, then you say 2x minus 5. Say it again. It's y minus 5 minus y.
Right.
5 minus y. And then you plug this into there and say 5 minus y, 5 minus y, plus 3y is equal to 8. And from that expression over there, you find the y. Okay? But the same thing here. What we're going to do is that from this first equation, I'm going to find the x as a function of the y, if you like. Okay? What's my x? Is my beta 0. Okay? I know from mechanical properties, or just by doing the algebra here, that beta 0 hat will simply equal to y bar minus beta 1 hat times x bar. Okay? You can show that from that first order condition. If you don't know how to do that, look at some of the videos where we proved some of these mechanical properties and how we transform that first order condition to an expression that looked like this. Now, in order for you to be able to do this, of course, you need this algebra bit. So you need to understand those summation notations and how they operate. If you didn't know that, you couldn't have gotten to that. Okay? You could have memorized this. You could have memorized that, oh, this holds. But of course, it's always better if you can derive it and you fully understand those algebraic steps. The moment you're done with this stage here, then the rest should be relatively simple. You go into the second equation, you say xi, yi, instead of the beta hat, I'm just going to plug in y bar minus beta 1 hat times x bar minus beta 1 hat times xi is equal to 0. So far so good? What's the final bit? The final bit is to rearrange everything so you only have beta hat on one side and everything else on the other, and you'd be done. It's as simple as that. The steps are very simple. They're very similar to what you would have done when you solved systems of simultaneous equations. Okay, okay, so let's do this. Sum xi, I'm going to rearrange stuff a little bit here. Yi minus y bar plus beta 1 hat, or minus, let's do minus beta 1 hat, minus beta 1 hat, xi minus x bar. And of course, all of this, let's not forget brackets are important, they're all under this summation notation. Okay? And all of this is equal to 0. So far, so good? Yeah, everybody with me? Okay. Well, the summation notation is a linear operator. Okay, so I can bring it out and put it on the other side. So I could just write here sum of xi, yi minus y bar, the first part, minus sum, or beta 1 hat is a constant, can be pulled out of the summation notation, xi times xi minus x bar is equal to 0. Agree? I'm done now. I can send this to the other side and divide both sides by this. So send this whole thing on the other side with a plus, right? And divide by this. So I'm going to do two steps at once. So I'm going to say sum xi yi minus y bar divided by sum xi minus x bar is equal to beta 1 hat. Done. You could have said, I'm done. What did I do? Nothing more complicated than x plus y is equal to 5, 2x plus 3y is equal to 8, find x and y. Okay, and then I could have gone here and plugged this into the beta 0. Okay, I could have taken this and plugged this here into the expression of this beta 0 to find exactly what beta 0 is. Okay, now, if someone looked at the lecture notes, you might be a little bit puzzled by this, right? Why might you be a bit puzzled by this? Why might you be a bit puzzled by this? Is because in the lecture notes, really what we observe is not this, but really we observe an equivalent expression which looks more like this. xi minus x bar, yi minus y bar, over sum of xi minus x bar, all of its square. See, if I give you a minute, we've already done this in one of the classes, so if you've been following up the videos carefully, you'll actually know already the answer to this. You will know why those two expressions are equivalent. But see if I can give you a minute, and if you can come up with an answer as to why those two expressions are equivalent. But for now, I'll stop this video.